So in this example, pause the video, take a moment, read the situation, and then we'll continue on. Okay, a survey was given to random selected high school students, 9 to 12, and whether or not they want possible changes to the school's canteen. That's just the school cafeteria. So the first thing you'll notice a 2x4 contingency table. That is the observed table. This is the survey, the results of the survey collected and recorded and tallied up into, for example, freshmen who want canteen changes. So there are 7 freshmen who wanted changes to the canteen. There are nine juniors who don't want changes to the canteen. So the first thing we want to do is just find the sums of each of those rows and columns. And when we do that, we find that there's 21, 21, 22, and 21 here. There are 43 total that want change and 42 that do not want change. So the complete total, so the total number of people surveyed is 85 students. So to calculate the expected frequency table, there is a way we can do this with our calculator, but I'm going to again go through the process here of doing it by hand for a couple of the cells. So for example, if I wanted to calculate the expected value for sophomores who want changes to the canteen, I would take the row total times the column total divided by the table total. So for that cell, that would be 43, times 21 divided by 85. Okay. If I wanted to do, for example, this cell right here, this would be seniors who don't want canteen change. So that would be, there were 42 total here, the column total is 21, and the table total was 85. So that would be 42 times 21 divided by 85. And if you do those for the remaining cells, you should end up with what you see on the board here regarding the expected values and the sums. Okay. So at this point, we're going to go through the 7 steps of the chi-square test, and I'm going to show you a little bit of the calculator work. So here we go. So the null hypothesis and alternative is simply stating that these two things are independent, and then that those two things are not independent. It's as simple as that. Just state whatever the two variables are independent, and then whatever those two variables are not independent. The degrees of freedom comes from, again, your observed table. So the observed table in this case has 4, right? So, 2 rows, right? So I plug in a 2 here, and it has 4 columns. Notice I'm not including the sums, right? When I calculate the degrees of freedom, I do not include the sums, rows and columns in that calculation. So I end up with 2 minus 1 times 4 minus 1, and that gets me 1 times 3 is 3. 3 degrees of freedom. Significance level. Notice we have a 5% significance level. They tell us. That's not something that we normally have to choose. So we're just going to simply state 5%. So quote the significance level, 5%. Next step, the rejection inequality. This is what I'm talking about. We reject the null hypothesis if, and then this right here, right? So this right here is something you state every single chi-squared test. We reject the null hypothesis if chi-squared calculation is greater than, and then we have to determine that critical value. Well, according to that chart we used previously, we have a 3 degrees of freedom, and we're still using 5% significance level, which means 7.81. 7.81 is that target number that we're going to compare our own calculation to. So I'm going to fill that into my blank there. And now at this time, I'm going to use my technology to calculate chi-square. And this is where you're going to need to make sure you pay attention, follow along with your calculator at this point. So if you pull up your calculator, whether you're using a handheld or the Wabbit, doesn't matter which one you use. Let's check it out here. So using my Wabbit or your handheld, I'm going to go to second. I'm going to hit second, and then the matrix button, which is the fourth button below the second button. And you should see a menu like this. And then I'm going to click over to Edit. And I'm going to hit Enter on matrix A. So notice it's a 1 by 1. I need to change that to a 2. So I'm going to type in 2, Enter, 4, Enter. And notice my matrix should look like my table that I see from up above, the observed table, a 2 by 4. So I'm going to fill in that data. So 7, 9, just type in each number, hit enter, and it'll take you to the next cell. Notice where that cell moves horizontally and then drops down to the next row. 14, 12, 9, and 7. So I type in my observed table, and now I'm going to go and actually do my calculation here. So I'm going to go to, you guessed it, Stat. I'm going to scroll over to Tests. Notice up at the top it says Tests. And I actually find it easier to scroll up. If you scroll up until you get to chi-squared test, that's option C. Hit enter. And then as long as you use matrix A, you don't have to change that. So that's why I often just use the same matrix A. Then I don't have to worry about changing that. Don't worry about the expected matrix B. So you can just arrow down or just hit enter down through those options and then calculate. And boom, there's our chi-squared calculation. Notice we didn't have to work out all that whole table calculation. Notice the other things that this gives you. It gives you chi-squared, it gives you the p-value, and it gives you the degrees of freedom, which we should just be verifying for what we did. So using technology, we have found that 5.81, our calculation is 5.81 to 3 sig figs. So here's what that means. If we take a look at comparing our calculation, right? So our calculation was 5.81 to our critical value. Our calculation is less than the critical value. So that means we fail to reject the null hypothesis. In other words, again, we fail to reject. That again is a fancy way of saying we accept the null hypothesis. Now the p-value. Our p-value is also, we can also see from that screen. The p-value is 0.121147, so on, so on, so on. So our p-value, I'm going to fill it in here. Our p-value is greater than, in this case, 0.05. So notice that 0.05, that is the significance level. Significance. That is the significance level as a decimal. So if our p-value is greater than the significance level, that means the same thing as what we just interpreted. That means that we are going to reject, or fail to reject rather, the null hypothesis. So that means that gives us further evidence to not reject the null hypothesis, right? We fail to reject. Therefore, we can conclude that, according to this example, your group and wanting change in the cafeteria are independent. That means there is no relationship between these two things. One does not affect the other. The steps to using technology are here. There are a few videos that I will provide, but you can also do a quick Google search of using your graphing calculator and running a chi-square test as well to help you enter the observed table into a matrix and then running the test itself. But just be aware, we are running a chi-square test, option C. It is not option D or option B, it's option C.